Welcome to the video on relative velocity. In this video, we're going to look at scenarios of cars passing each other, where we find the unknown velocity of one vehicle if we know the velocity of the other. In this video, we're going to be looking at two different scenarios. In the first scenario, a semi-truck passes you while you're traveling in the same direction. In the second scenario, a semi-truck passes you while you and the semi-truck are traveling in opposite directions. Question 1. You are driving your car with a velocity of 30.6 meters per second when you are passed by a 22-meter long semi-truck traveling in the same direction in a time of 12 seconds. What is the velocity of the semi-truck? For all physics questions, it's always a good idea to draw out the scenario. So let's start this question by making a drawing. In this scenario, you're traveling with a velocity of 30.6 meters per second. The semi-trailer is traveling with a velocity that is unknown. Your car is initially in front of the semi at time t is equal to 0 seconds. 12 seconds later, your car is behind the semi. During this time, the semi covers a distance of 22.0 meters, or the length of the semi. We solve this question using the velocity equation. Velocity is equal to displacement over time. Because the semi is going a little bit faster than you in the car, this means the semi is going to travel a little bit further in the same amount of time. So we set this up as a difference of velocities. So the velocity of the semi minus the velocity of the car equals the little bit of displacement extra the semi travels in the time that the semi passes the car. We're now ready to add some numbers and solve for the velocity of the semi. So the velocity of the semi minus the velocity of the car, which is 30.6 meters per second, is equal to the extra displacement that the semi-truck travels, which is 22 meters, and the time that this extra travel takes place in, which is 12 seconds. Dividing 22 meters by 12 seconds, we get a velocity on this side of 1.83, repeating decimal, meters per second. And adding back in the rest of our equation, so we have the velocity of the semi minus 30.6 meters per second. To get the velocity of the semi all alone, we have to add 30.6 meters per second to both sides. And our negative 30.6 meters per second cancels out with our positive 30.6 meters per second on this side, giving us a velocity of the semi equal to 32.4 meters per second. Now, just for some extra practice, we can convert this velocity in meters per second to kilometers per hour. It also lets us better compare it to our 110 kilometers per hour. So we multiply by a conversion factor that cancels out our seconds and gives us our desired unit of hours on the bottom. So our seconds cancel out. There's 3,600 seconds in 1 hour. Next, we have to cancel out our meters, so we use a conversion factor with meters on the bottom and our desired unit of kilometers on top. There's 1,000 meters in 1 kilometer, and our meters on the top cancels with our meters on the bottom. This leaves us with a quantity that has a final units of kilometers per hour, just like we desire. And 32.4 multiplied by 3,600 divided by 1,000 gives 117 kilometers per hour. In summary, we found that the semi-truck travels 117 kilometers per hour, which is 7 kilometers per hour faster than the 110 kilometers per hour that you were traveling in your car. Now let's look at a question where the semi-truck and the car are traveling in opposite directions towards each other. In this question, you are driving your car with a velocity of 30.6 meters per second when a 22-meter long semi-truck traveling in the opposite direction passes you in a time of 0.37 seconds. What is the velocity of the semi-truck? Again, we start by drawing a diagram of the scenario. As we had in the first scenario, you travel with a velocity of 30.6 meters per second. The difference being that in this scenario, the semi travels in the opposite direction with the velocity we're trying to find. We have the car initially passing the front of the semi here at time is equal to 0 seconds. And then the car passes the back of the semi at time is equal to 0.37 seconds. Similar to the first question, a displacement of 22 meters is covered during this time. Again, we start with our equation for velocity. Velocity is equal to displacement over time. Unlike the first example where we looked at a difference in velocities, in this example, we actually look at a combination of the two velocities. This is because both the velocity of the car and the velocity of the semi-truck combine to cover this extra 22 meters because they're going in opposite directions. So the velocity of the semi plus the velocity of the car equals the displacement covered by the two vehicles in the time it takes to cover it. If you're struggling with understanding this scenario, another way to think about it is if the car was moving and the semi-truck was stationary, how fast would the car have to move to cover these 22 meters in 0.37 seconds? Well, if the semi-truck was stationary, the car would have to move at its velocity plus the velocity of the semi to ensure it still covered this distance in 0.37 seconds. Now we're ready for some numbers. The velocity of the semi is the quantity we're looking for. We add the velocity of the car, which is our 30.6 meters per second, and this equals the 22 meters that the two vehicles cover with their respective velocities and the time that they cover it in, 0.370 seconds. 22 divided by 0.370 seconds is equal to 59.459, repeating decimal, meters per second. And if we add back in the other side of our equation, velocity semi plus 30.6 meters per second. Now if we want to get the velocity of the semi all alone, we have to do the opposite here and subtract 30.6 meters per second from both sides of the equation. And our positive 30.6 cancels out with our negative 30.6, giving us a velocity of the semi equal to 28.9 meters per second. As before, we can convert this velocity to kilometers per hour so we can better compare it to our 110. So we have a velocity of 28.9 meters per second, and we want to multiply this by a conversion factor that has seconds on top and hours on the bottom, giving us our desired unit of hours. There's 3,600 seconds in 1 hour. And we also multiply by a conversion factor to cancel our meters. So we have our meters on the bottom and our desired unit of kilometers on top. There's 1,000 meters in 1 kilometer. So our meters on top cancels with our meters on the bottom, and our seconds on the bottom cancels with our seconds on the top. If we multiply 28.9 by 3,600 and divide by 1,000, we're going to end up with a velocity of 104 kilometers per hour. So in summary, we were looking for the velocity of the semi-truck and we found 104 kilometers per hour. This is 6 kilometers per hour slower than you in the car going the opposite direction of the semi-truck. Thank you for watching this video on relative velocity.